Hey there, fourth graders. So we are getting into patterns with numbers. So we've talked a lot about adding, subtracting, multiplying, and dividing numbers. We've talked a lot about place value. We've looked at how we can use all of that in real world situations or word problems. And now what we're going to do is go and dive a little bit deeper into helping us develop number sense. And so we are going to do that by looking at how numbers relate to one another. When we have a pattern with numbers, the numbers all relate to one another in a certain way. Generally, it is through addition, subtraction, multiplication, or division, where you're either adding a consistent number, you're subtracting a consistent number, you're multiplying a consistent number, or you're dividing a consistent number. And you've been working with patterns probably since you were a little baby. That's like one thing that a lot of times you see, people doing is starting to do like square, triangle, square, triangle, square, triangle. And what we're basically doing now is just getting into more complex patterns where we have to determine what the pattern is so that we can continue the pattern. Okay, so it's not really anything that you haven't done before. It's just something that we're doing in a little bit of a different way, looking at it with numbers. So one thing that I want to point out is that we have our four operations: addition, subtraction, multiplication, and division. All right. Now, we know addition and subtraction are inverse operations, which means they're the opposite of each other, and multiplication and division are inverse operations, which means they're the opposite of each other. We also know that when we add or multiply numbers, those numbers get bigger, right? Because we're putting more in. We're either adding more groups or we're adding single items or single numbers. Okay. And when we're subtracting or dividing, our numbers get smaller because we are taking something away or we're splitting something up and distributing it between equal groups. So that can help us with our number patterns, because right here I see two examples of number patterns that are getting bigger. And right here, I see two examples of number patterns that are getting smaller. So I know because these are getting bigger, I'm not likely to be using addition or multiplication. And here, I'm not likely to be using subtraction or division. Here I am likely to be using, sorry guys, I am likely to be using addition or multiplication because they're getting bigger. I was thinking about it backwards. And here, I am likely to be using subtraction or division because the numbers are getting smaller. Okay, so that helps us to help figure out what we're doing, because here I'm either going to be adding or I'm going to be multiplying. And the key is to remember that I have to do the same thing every time for it to be a pattern. A pattern isn't like I add 2 and then I add 5 and then I add 3 and then I add like some random number. Like there's a consistency in a pattern. Just like when you first started learning about patterns, you knew triangle, square, triangle, square, triangle, square. The next one's going to be a triangle because there's consistency. It's not like you go triangle, square, triangle, square, triangle, square, 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 triangle, square, triangle, square. That's not how it works, right? So a pattern is consistent, and that's what we're going to do the same thing with numbers. So the first thing that I always check to see is it an addition pattern? This one gets bigger, so it could be. Well, 1 plus what equals 4. So I want to think, how can I get from one number or term to the next number or term? Each item in a pattern is considered to be a term, okay? And you'll see that a little bit more in our next video. Well, if I get from here to here, 1 plus what equals 4? 1 plus 3, okay? Does 4 plus 3 equal 16? No, right? It doesn't. So that's where I'm going to say, okay, well, let me try multiplication. 1 times what equals 4? 1 times 4 equals 4, right? 4 times 4, does that equal 16? Yeah. So it looks like I found my pattern, all right? So if 1 times 4, 4 times 4, okay, that works. So now I have to figure out what 16 times 4 is, and I'm just going to write it over here on the side, and I'm going to solve it super fast because sometimes we just have to do that, right? 4 times 6 is 24. Right, the 4 we group by 2. 4 times 1 is 4, plus 2 more is 6. So 64 could go here. And if I wanted to double check and make sure that I'm correct with my pattern, I would try out and make sure 64 times 4 equals 256. Well, 4 times 4 is 16. Regroup by 1. 4 times 6 is 24, plus 1 more is 25. So yes, that one is correct. And in this case, every time I multiplied by 4. That was my rule for the pattern. Okay. okay? So with patterns, we have terms. Those are the numbers that are in the pattern. So this is term 1, this is term 2, this is term 3, because this is the first one, this is the second one, this is the third one, all right? And we have rules, and the rule is what we're doing over and over again to figure out what comes next in the pattern. All right, so let's look at this one. In this case, we also have a number sequence where the numbers are going up, which means multiplication or addition. Like I said, I always start with addition. So 6 plus what equals 12? 6 plus 6 equals 12, okay? 12 plus 6, 12, 13, 14, 15, 16, 17, 18. Ooh, looks like I found it. It's plus 6. That's my rule. I'm adding 6 each time. So if I do 18 plus 6, well, 18, 19, 20, 21, 22, 23, 24, and 24 plus 6 does equal 30. So that one is correct. Now, you may have also noticed, if you're really good at skip counting, you may have said, oh, Mrs. Long, you're also skip counting by 6s. And that's true, but if you remember, when you're skip counting, you're adding that 6s each time, or you're adding 3s each time if you're skip counting by 3s. So that is why that works, right? All right, so let's look at this next pattern. All right, here my numbers are getting smaller, which means I'm going to be using subtraction or division. So if I have 42 to get to 35, so 42, I'm going to try subtraction first. 42, 41, 40, 39, 38, 37, 36, 35. So I subtracted 7. So 35, 34, 33, 32, 31, 30, 29, 28. Ooh, yep, subtracting 7, that's my rule. You may also notice that we're skip counting backwards by 7s, so you could use that to help you out, right? If you're really bad at going this way when the numbers are getting smaller, work this way. How much is it from 28 to 35? How much is it from 35 to 42? You can go the other way because the pattern will work the opposite, like 256 divided by 4 is going to equal 64. 64 divided by 4 equals 16. In this case, I could just subtract 6, subtract 6, subtract 6. So the opposite operation works. And if you're having a hard time figuring out what the operation is, then that might be a good way to do it, okay? So 28 minus 7, I have to subtract 7 again, equals 21, and then minus 7 would equal 14. All right, and my last one. All right, I don't have as many numbers, so that can make this a little bit trickier, but here's where I'm going to actually switch over to a pencil, because you should be doing your math in pencil anyway, but I want to be able to erase. So if I do subtraction first, 40 minus what equals 20? 40 minus 20 equals 20. All right, if I do 20 minus 20, what would I get? I'd get 0. Does 0 minus 20 equal 5? No, right? That doesn't work. So I'm going to erase that number and I'm going to try division. Well, 40 divided by what number equals 20? I have no idea. But if I look at this, I know 20 times 2 equals 40. So that means 40 divided by 2 equals 20. Well, then 20 divided by 2, that equals 10. And 10 divided by 2 equals 5. I would say division patterns are probably the most difficult, but they're also the ones that you're going to see the least. So, and again, you can work the opposite direction, and that might make it a little bit easier for you. All right, so again, with number patterns, we're wanting to think about what are my terms and how are they related to each other, and remembering that the rule is going to be consistent as we're working through it. All right, this is a really fun lesson. I love doing patterns. I hope you guys love it too, and I will see you in the next lesson. Bye, guys.